And welcome back. Now, as you can see from my workbench, it's full up with bits and pieces all attached to this ATTiny85, and the idea was to have a slightly longer look at this, also look at the shield that it's currently built on, and to see whether we could get something like I2C running on it, and possibly, well, with a bit of luck, SPI, and well, just see what we can do with the ATTiny85 given the small amount of pins available to us, GPIO pins that is. So let's see how all this came into being and how successful I was. So here we have the ATTiny shield components that I have mentioned in a couple of previous videos, and it comes in this very nice little compact bag, a couple of PCBs in here. So let's just unpack this and see what we get for our money. And just a quick reminder where I got this from, you'll see this from the last video too. Right, so these are the main components that come with this shield kit, and it's these center ones that actually make up the kit itself, and that in itself is not major. It's not a massive thing to build. But you do get a couple of extras that I think are worth mentioning. One, you get this little mini kit here. When you build all this, the idea is that if you upload the test example sketch that I guess must be somewhere in the examples for the ATTiny85, what it does is fade this LED here in and out with all the different colors. It's obviously an RGB LED there, a few transistors, on off switch, header pin, and the socket for the ATTiny85, and that's very nice little PCB here. Yeah, very nice, very smart. So that's the extra you get with this, just to prove that you can actually upload something to it. And I think that's probably worthwhile having. So this one here is the actual unit itself. I've got to be honest, I don't like these sort of header sockets, these round ones. I've had problems with these, so I'll probably be replacing these with my own. And let's face it, they are only pennies, so it doesn't make any difference. That's the ATTiny85 you actually get with it, so that's good as well. And there's the little tiny board. So the idea is you build all this together, plug this into your standard Arduino IDE USB port, and program away. Now, of course, there are some things on here you can't do, and you have to be aware of that. We'll be coming on to that as I build this and move it forward. Now, the purpose of this video actually is not simply to build this, as useful as that might be. I want to get this ATTiny85 running with I2C so that I can display stuff, say on an LCD display, for example. As an added bonus, it would be useful to get SPI running, but we'll see how far we get with the I2C first. Now, the other thing you get is this little packet here. Sticker labels, it says, and if you notice, look, they stick on the side of your, well, I guess your Arduino. Oh yes, it says Arduino up there, as a sort of a little bonus really. So in fact, what he's done, he's commercialized what I do with my development board anyway. Look, I do this, I just stick my own stuff on there just so I can identify my pins. Well, now he's given us some really nice pretty ones, look. So yeah, I'll have to do that, I think, for my other board. I haven't got these on, I think I've got these on two boards at the moment, but I've got a third board somewhere, so I'll have to do that and hopefully remember to show you. Now, it also comes with the soldering instructions, which I guess if you know how to solder is going to be pretty straightforward anyway, but there we are. Oh, that's good. Yeah, well, it's for both, look, the RGB tiny extra board plus the main one. Right, so the purpose then is I'm going to get this all built. I might take a couple of pictures as I'm doing it just to show you the progress, but basically the idea, as I say, is to get this up and running, get that one up and running as well, just to prove that we've managed to program an ATTiny85, which of course we already know we can do because of my previous video, which showed us how we can do some very simple stuff. But then I want to get I2C running, and that's got nothing to do with this hardware and everything to do with the library, or libraries I should say, that you can find on the internet. There are in fact two libraries I'm going to try and use. One's for master, one for slave. In this case, I do actually want this to be a master. That is to say, this will send out the instructions and control all other I2C items on that bus, so like the LCD display, for example. I could, I suppose, think about having this as a slave with a standard Arduino as master, but I don't know, that might be going a step too far. We'll see. Right, next time you see all this, then it should be pretty much built and hopefully have this fading LED all up and running, and then we can move forward from there. Great. Right, so here we have on the workbench a fully assembled ATTiny85, and as you can see, it's looking okay. So it's built, and as you can see over here, try and look past all these wires. We'll come on to that in a little bit. Let's talk about the construction of this actual device then. There are a few pictures here. I'll show you this and talk you through that. Here's the main board with the two different types of socket header you can get. On the right it's the one supplied, and on the left the one I'm actually going to use, and you'll see why. So here's me just putting a few bits together, and it's all fairly simple stuff. Not that many things to actually solder together actually. And there it is, all nicely done, look, pretty neat. Oh no, the two end sockets pins I haven't actually soldered in yet. That was just so I could stand it up. And these tools we're talking a little bit more about in a minute, because they're absolutely essential for this sort of work. That's just another picture of it. Yeah, the two end pins obviously have got to go into the Arduino. So this is the RGB fader. That was even simpler to put together. Now look at all the flux there on there. That's not good. Leaving flux like that just, you know, is going to cause shorts and things. So if you can see that, I'm using some PCB and flux cleaner and a sort of a hard toothbrushy thing. And look how beautifully clean it is. That's how it should look. So just a very quick word about ICs. When you get them like this, they're actually splayed out, the legs, as you can see. If I put my hand there, you can see they're very slightly splayed out. When they're splayed out like that, not absolutely at right angles to the body, there's not a chance in hell that you'd have to fit them into one of these, right? It just isn't going to go. What you actually need is a tool like this. These are cheap, find them all over the place. They're double-sided. This is for the dills that are thin, and these are the fat ones. There's probably a proper term for that, I don't know what it is. Anyway, all you do, you drop your IC into there like that, and then just squeeze this. There we are. And then take it out, and lo and behold, all your pins now are at right angles to the body. You see that? And that will now fit into one of these sockets, no trouble at all. See, that will go in there. I can just push that in, and in it will go. But I don't want it in that one, I want it in the other one. Right. So that's it, just a quick word about this. And also when it's in, you then need something like this. This is an IC puller. In fact, so let me put that into that socket just so we can see it. That goes in there. Now if you want to get that out, yes, you can put a thin little blade or something underneath there in that little tiny gap that you can just see through there. Or you can use one of these, which is an IC puller. Whoops. Trying to look at this and the cameras obviously are too much of a challenge for me. So you put this in here like so, and then because you're applying pressure straight up like that, it doesn't bend any of the pins when it brings them out. I know they look a bit wonky, but it was like that before we put it in, wasn't it? Okay, so that's the two tools that are useful, and I would say in fact this one here is absolutely indispensable if you're working with ICs. As you can see, this one's pretty old now. I've had it for donkey's years. So there we are. Okay, so building it wasn't particularly hard. However, as I mentioned when I opened up the project, or the little package I should say, this thing here, I did go through some of the components, and I said these little header pins here I wasn't going to be very happy with, because I've dealt with these before. Now as you can see, this sort of, well, it's not a DuPont cable, but this sort of hookup cable fits okay in these holes. If I can find it, there we are, that fits in. But of course I don't use those. In fact, I hate them with a passion. They're too thin and fiddly. My standard DuPont cables though, and here's just one of them peeled off a whole strip, that wouldn't fit into one of these holes for love nor money. I mean, you just won't get it in, it's too big. Look, I mean, you can see that the DuPont cable there is much squarer for a start. It's not round like these pins are. So I'm convinced that I actually made the right choice there in replacing these ones with some standard header pins on here. So there's one set here and one set at the back. So that's the first thing. If you're going to build this, I would say don't use these. You'll be sorely disappointed when you try to use your DuPont cables. And it's I mean, if the person who put all this together is watching this, then I would strongly recommend you reconsider using these type of pins. These are mainly used, I think, for things like ICs with round pins or those LED matrices, but not for DuPont cables. So I wouldn't say use those. Everything else seemed to be okay. Everything fitted. The instructions were pretty clear. What wasn't clear was one little tiny point about this little jumper cable here. This little jumper can go on to 3.3 or 5 volts, and it says in this booklet for experimentation, in fact it says it down there, you can probably just catch it. It says for test purposes 5 volt or 3.3, but I'm not quite sure what it actually does on the board. I was only playing about with it today and I thought, well, I don't know what it does. I mean, it's still working. Oh, now it stopped working, but it's still working with it or without it, so I just put it on anywhere. There we are. Now that should spring back into life, I hope. Did I turn it off accidentally? Oh. See what I mean? You start videoing and something that's been working for the last 3 days has a mind of its own and goes, no, I'm not working anymore. So let me get this all back up and running and we'll continue. And we're back. Right, okay, so when I took that little jumper off down here, it of course killed the power to the actual processor. And basically what I've discovered is that the 5 volt or 3.3 volt connects down into the Arduino down here, and basically you're selecting the power that you want to run this on. So at the moment it's running on 3.3, and I've not noticed any difference whether it runs on 3.3 or 5, frankly, so that's always a good little test. Now, as you can probably work out just a little bit on this screen here, now this screen, incidentally, a bit like the LEDs, is a beautiful blue, deep blue sort of sea blue, Mediterranean blue, with white writing. You're seeing it on camera here as a really washed out, it's awful. It's not like that in real life, and the only way I can get that to look like blue is to make the whole picture really dark, so you'll just have to use your imagination a bit there. But what you can see just at the back there is the number 26, and it's frozen. It's supposed to be counting up, and it's frozen. So what I've discovered is that when you run certain programs, specifically I2C on here, and you leave it connected up to the Arduino, it freezes the program. If I just unplug that bit at the back there, look, now you can see at the back it's jumped to 85, 86. I mean, the program was running, but it couldn't send out this signal to the LCD. So let's talk about I2C. Was that easy to set up? No. I found this particular Arduino Playground article, which was, well, it was okay. Let's have a look. It's on my browser here. So this guy here originally wrote it, but as he says here, it's been years since he's used it, and I followed it down and found all the links for his libraries and things. Let's have a look. Where is it? So we're looking at an I2C master. That's what this ATTiny is running as. You can run it as a slave as well. It shows a example here. There's a modified liquid crystal library, and that's where the fun started, really. Yeah, the example that he had, this one here, although it was fairly similar to the one that I've used for a while now, probably the last year or so maybe, it wasn't quite the same, and no, it wouldn't work on here at all. So what I had to do, I'll in fact go back to my monitor just to show you the hoops I had to go through to get this to work. If I go to my monitor, and you'll see, hopefully, there we are. So you see this one here. Now this bit here, can I make it any bigger? A little bit. There we are. So now what you can see there is 4 files, right? It says the liquid crystal I2C CPP and header.h original. They're my originals, and then the tiny versions. So what I did was went through his code, saw where he'd made the changes, but then did a comparison line by line and copied my code back into the ATTiny85. So basically the ATTiny85 is exactly the same as my original, bar a few if statements. which basically says if I'm running in Tiny85 mode, don't load up the wire.h, load up the TinyM wire.h and things like that. So that took quite a bit of fiddling about with, as you might imagine, but at the end of the day it was probably worth it, because, well, it is most definitely worth it, because I've got I2C running on here, no trouble at all. That modified library for I2C, or rather for the liquid crystal one, I will of course put down at the bottom of this video, okay, so you can use that and hopefully that'll run without any issues. Now, as I mentioned before, this module was easy to construct, but if you're going to use it as it's intended, that is to say plugged into an Arduino, you'll need an Arduino Uno, that is, right, full-size board as I have here. Now luckily I've got my nice new fresh red one, and so it worked pretty well, and then it just plugs in either side so that you can then program the IC. Now what does that mean? If you want to program the IC, well, there's firstly something you need to do. So if we go to the code window, so this is the code we're running on the actual ATTiny85 at the moment, but you can't do that until you've programmed the Arduino first as a programmer. So what you have to do, you go to, let me say, tools. Oh no, it's not, it's on the file, examples, Arduino ISP, and there's an Arduino ISP sketch. Now what you have to do is load that up as per normal for the Arduino Uno that you've got down there, and basically program your Uno as a programmer. So if you're going to do this a lot, I suspect it will get a bit fiddly. You really need a dedicated Arduino Uno to do this. So okay, let's assume you've done that. Then it's just one sketch, you just plug it in and compile it, and that's the end of it, right? Then you can compile sketches for this by plugging in this unit in there like that. Now you'll see that that little LED there starts pulsing. It's called a heartbeat LED. So what happens is that this pulses to show you everything's okay. So this board is now communicating through the pins at the back here, the standard SPI pins, and the power through here, of course. Now you're probably thinking, hang on a minute, how do I get the Arduino IDE to recognize that there are in fact ATTiny85 boards available? Okay, that's easy to do as well. File, preferences. Now down here where it says additional boards manager URLs, click that little thing on the right. Can I expand the window? Yes, I can. Oh, it's a long window, isn't it? Right, okay. So this line at the bottom here, I think that's the one, isn't it? Yes, is the one where you can get your ATTiny stuff from. So I'll put, well, I might as well put all these on here actually. I've got Spark Funds on there and the Digistump ones, ESP826. So I'll put this on as well, but this one basically downloads the boards. What you then do when you go to Boards Manager, Tools, Boards, hang on, we've got to go right to the top of Boards, and there's Boards Manager. What that does is read that list of places in which to get board information from. Like you can see, it says downloading platforms index, which basically means I'm getting information about the boards you've told me about, and somewhere down here it will say ATTiny, somewhere down here, there we are, ATTiny by David A. Mellis. Thank you very much, David Mellis. That's great. So you click that, and of course mine's already been installed, so all I've got is a remove button, but you all have an install button. You install that, and then as if by magic, when you do go to tools now, and when the Arduino responds, because obviously it's now thinking about all those boards I didn't load up, you'll get in your boards, when you scroll down, you'll get those two entries as well, ATTiny microcontrollers. So once you've done that, then you have to go to your code window. So let's go back to the monitor. Now to program this, what you need to do is say tools. The board has got to be the ATTiny85, as you can see there. So somewhere on all this lot, there it is, ATTiny85. Well, that series 24, 45, 85. Now when you select that, be careful. You select that one, but then you have to go back to tools. It takes a little while it's thinking about it. There we are. And then you have to select from here ATTiny85. By default it will select the 25, which is not what you want. And also you notice I'm running here at the moment, well, I think I'm running anyway 8 megahertz, by default you'll be running at 1 megahertz. Okay, and then of course you have the COM port. It's just the standard COM port for your Arduino Uno, and that's all you need to do really. And then it knows about it. I mean, do the blink sketch first, make sure that's working, but really I think in all honesty, yeah, that's pretty simple and it works okay. Okay, so then you've got this unit all soldered up and plugged into your Arduino. You've changed your Arduino to be the programmer. You've plugged this in. You can program this as well. Great. Then what? Now, you might be thinking, what the hell are all these wires doing here? Well, it does say in the browser article that I was looking at here, it says you must use a pull-up resistor on the two I2C wires. Now in fact it says use 4.7k resistors, which I didn't. I used 10k because I didn't read the manual, as it were. But there we are, look. Whoa. Be sure to use pull-ups, 4.7k on 5 volts. Right, I2C with these lives are not so giving. Well, I tried it with and I tried it without, and it worked both times. But when I was doing another sketch, it wouldn't work. So I actually put in down here some pull-up resistors. These two pins here, which are the I2C pins, now have pull-up resistors, these two here, to plus 5 volts. And the reason it looks all a bit convoluted is because there's no space on the board to do that. So having got this working, as you can see, it's working fine as long as you disconnect the board, these back pins. So if you look here, look, so these back pins are disconnected, these front pins are still connected to power and so forth. It's all working pretty well. And I've obviously just done something because the display is all corrupted now. Oh dear, these things are sent to Christ. So what else can we do? Well, I've tried a few things. I tried to get SPI working instead of I2C, or as well as I2C. I didn't know if that was going to work. Couldn't get it working because I tried to get a temperature sensor working, a DS18B20. Pretty standard. I've done a video on it before. I tried it with my waterproof temperature sensor, the DS18B20. Wouldn't work. Even though the sketch said I'm running and it compiled fine and everything, it said it wouldn't work. Tried the same sensor on a standard Arduino board and it wouldn't work either, so I guess it was faulty. So I've got a couple on order, and if they arrive before this video goes out, I might just tag on a bit of the video at the end. If there's no video on the end of this one about the DS18B20, then I guess it didn't arrive in time, or I didn't get it working. But there is good news though, because as well as getting I2C running on for this board, let's just disconnect this and get that board back up and running. Right, switch off, switch on, and hopefully this will all spring into life. There we are. Hello world, and it's counting, I don't know, the orders or whatever. Okay, now as well as that sketch, I've got another sketch that's running that does a little tiny bit more, and I thought it would be a good test for it. So let's get that loaded up. So which one is it? So this is the sketch. So this is a fairly standard Uno type code base for NeoPixels, which I did in the TV simulator. So we're still using liquid crystallized squared C on here, and I've put in quite a few notes. Now, although this original program I think was one of the example ones, I've had to make a few changes here and there to get that working, but this will also be in the video below all this, all right, in the video description. I'll put a few notes, some of which are mine, some are not. Oh yes, talking about the actual, well, the address of your screen depends very much on how you've soldered the pads at the back. Now on this one, if I can just show you this very quickly because it's important to get it working. This backpack chipset here that plugs into here to make it all working on I2C, if you notice there are 3 pads here, A0, A1 and A2. Now I've put a link in the code to say what does this address change to when you put a blob of solder between these. Okay, by default I think it's hex 3F, the code will tell us in just a sec. Let's go back to the code window. Oh yes, 03F, there it is. So that's by default, but if you put solder pads on those other one, it will change that. And this document here tells you exactly what the address will be, and it ranges from, there we are, 038 in hex to 03F in hex. Okay, right. So having got that still running, I then included the NeoPixel stuff, which was all about, where is it, here, defining the number of LEDs, the fast LED library, untouched, because I wanted to see how it would work, and then just well, the same sketch that I used in my demo version of the NeoPixel stuff, okay, which might have been the one before the TV simulator. So let's just upload this, which means I'm going to have to plug this back in down here. Let me take me off. Right, plug that. Right, that's plugged in. Just make a check to see if that's okay. Yeah, right, let's upload. Now what you'll see down here are quite a few worrying error messages. Now are they worrying? Well, yes, they are really. One says not really a warning, just telling you fine, but the other one says you've redefined something. But the best error message, well, I say error warning message, is this one here. It says, look, well, oh, that wasn't supposed to happen. Invalid device signature. We'll do that again in a second, but there was a message here. Look, it says, warning, no hardware SPI pins defined. Well, that's right, I haven't loaded anything on here to make it work with SPI. So what does that mean? All SPI access will be default to bit-banged output. Well, bit-banged output is where the software is creating the timing loops and things like that to make SPI work, the protocol, which I think Nick Gammon has something on his site for that. Well, he most definitely has, because I was reading up about it last week. But I wanted the library to work, but I didn't realise in fact that this NeoPixel used that, but use it most certainly does. So let's see if we can just do that again and upload it. I don't know what happened there. What does it say? Let's have a look. Yikes, device signature. Ooh. Let's just, oh, I know what it is. Let me just show you. I said that you have to keep disconnecting these from here. Look, well, they're not, it's not plugged in properly, is it? Now it's plugged in. So now, hopefully, it will upload correct. It's just another little gotcha, if you like. So let's upload that. You'll still get the warning messages down here. Trolley long, off it goes, still doing stuff. It does take quite a long time to upload, I must admit, and I don't know why. Not really. Right, that's uploaded now, as you can see, and this bit banging software implementation of SPI is jolly good for us. So let me just go back to the workbench. There we are. Now I'll bring these couple of other things into shot, which is basically a potentiometer. Oops, one of them, and of course the NeoPixel display, which is that one there. So now if I turn this, there we are. And I'm not going to say this anymore, but of course what you're seeing here, it is not what I'm seeing. Okay, it's much more colourful and beautiful, but I think you can get an idea. Anyway, the point is that the NeoPixel display thing works absolutely fine, even though it's an SPI implementation. So, well, I guess we can get SPI working on an ATTiny85. I'm not quite sure how that's going to work for other items other than this, because obviously this is built in. The SPI bit of this is obviously built into the library. But, well, at least that's good news, isn't it? So long and the short of it is then, the ATTiny down here, it built okay, but do change those header pins to the standard DuPont ones. You do have to take this out of here when you reset it. So that, for example, if I switch off now then switch back on, it won't work until I take this out of here if I want I2C to run. So basically this thing here. Okay, if you're not worried about that, that will still carry on. You do need some pull-up resistors, it says on those two lines now, the SDA and S clock for I2C, although I must admit it did work for me both with and without, and I've only put them in, as I say, because things started to go wrong, but that was a totally different problem, a hardware problem, nothing to do with this. Now, okay, final judgment then really. So we got this tiny 85. It's only got a few pins on it, probably 3 or 4 at most that you can use. we've managed to get I2C running, so we get this working, and of course we've got an analog pin input now that's running on here, so this is obviously being read quite happily and it's responding okay. So, and of course SPI is running on the back to do this. So the question is it actually more useful doing it this way than perhaps with, I don't know, a Nano or something like that? Because I have done a video on a Nano 168, which you can get for very little money, but it's still more powerful than one of these. It runs at 16 megahertz and probably has twice the amount of memory of this, but half the amount of a standard Uno. And I don't know, I'm in two minds really, because once you've taken this chip out of here and you've soldered it to a socket, or pushed it into a socket that's soldered to a little strip board, you probably could make a circuit pretty small, but then you do have to keep taking it out of that circuit board to program it, unlike a standard Nano where you just plug it in via USB without all this faffing about. Here you've got a dedicated Uno with which to program it, and if you think, well, I don't need it dedicated, I'll just do it as and when, well, good luck with that, because you'll forget and then it won't be ready and then you end up not doing it. That's the trouble. If it's not available, it doesn't happen, does it? So I'm in two minds really. I think at the moment I'm probably leaning towards the cheapest solution of a Nano, which is a Nano 168. You can get it for about, I don't know, just over the $1, £1 maybe ish, and well, compared to a Tiny, well, I don't know, it depends if you want something particularly small. I did like the kit, I must say. The kit's nice, apart from those header pins, and it does come with these little stickers that you can put on the Uno to tell you what's what. That's quite nice as well, both sides. And on top of the chip itself, look, if I bring this right up to the camera, you can see that they're actually defined on top. Let me zoom in on that, it's worth looking at, I think. So there we, let me just hide that LED. It's upsetting the lighting. So there we have a little tiny sticker that goes on top of the chips, and it tells you the physical pins and then what they represent. So for example, we're plugged into pin 3, P3 that is, digital pin 3, which is physical pin 2, so that's quite a nice little touch. One of the plus sides is that the standard speed of these is 1 megahertz. Now, as I showed you, I'm running at 8 meg, but at 1 megahertz the current consumption of an ATTiny is absolutely, well, tiny, and in sleep mode it's, well, less than tiny, it's microscopic. So for battery operated equipment, this might be a very good chip to use. Okay, well, I'm going to leave it there because there's so much else we could talk about and discuss, but I think we've sort of gathered that the ATTiny85 is a useful chip, does a fair bit, you know, in the short time that I've been playing about with it. So yeah, good stuff, and nice little kit as well. And I would certainly recommend getting this kit if you're going to play about with ATTinys, just so that you can get this sort of setup working and you know that your ATTiny has been programmed successfully and things like that. And no, I don't get any commission from him. Oh, there's a thought. Oh, okay, we're going to leave it there. Right, here's a quick 10-second update. I've got the fader working, forgot all about that, of course. So here you can see it fading. You probably get a better idea of the colour by looking at the reflected light around here rather than the LED itself. But as you can see, because it's got 3 PWM pins, which is what you need for this RGB LED, it's working just as you would expect. Okay. And equally exciting is this sketch, which I finally got working with my DS18B20 temperature sensor, which is that one sticking there. As you can see down here, it says I've found one device, which is good because there's only one device on the bus. And it says the temperature is 26.56, and if in fact if I hold this in between my fingers, you should see it change pretty quickly actually. There we are, look, 2706, 28.19, and so it goes on up the scale, okay? And when I let go, it should be going back down again. As you can see now, we've got the LCD working and the One Wire DS18B20, so that's I2C and One Wire, all on the same ATTiny chip. There's one little tiny fly in the ointment which has just happened. As you can see here, this is the code that we've uploaded, and that's fine. But now down the bottom here, look, we're getting verification errors and first mismatch, which basically means we've uploaded something and the AVR Dude program has read it back and said, whoa, that's not what I thought I'd written. So that's a little bit worrying. It's only just happened this minute. I just uploaded a program prior to that and it was okay, and I've tried it twice and the same error comes up. So who knows, but that's a different problem for a different day. in the meantime, at least we're getting the I2C running okay for the LCD and the one wire for that. So that's good news. Thanks very much for watching. I do hope you like the other videos as well, and don't forget you can leave comments, where am I, down there, and suggestions for future videos and all sorts of things, and don't forget to share, thumbs up if you like it, and see you in the next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below, and if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.